2a is about two variable inequalities. What they do is they kind of throw in all the inequalities into one thing. So absolute values and linear and everything else like that we'll be talking about in this whole section. So we're looking at this. This is nothing new that we haven't done. It's just graphing this. So our intercept is -1. So -1 down here, draw a line, or a dot, I'm sorry. Our slope is 3. So again, it's up 3, 1, 2, 3 over 1, put another dot. And normally you would connect this with a solid line. But this right here determines everything. Because it's not equal to, and let me erase that so you can see it a little bit better. Because it's just greater than, this line has to be a dashed line. Okay, the dashed line means, okay, this is just part of it. Now, where is greater than that? And it's really pretty simple a lot of times to determine which one is greater than. Greater than is usually above the line, and then that's the case here. And you just shade above that line like that. Now you could test a point, and that's what they recommend doing to see if it works, but we'll get into that later. Now problem B says y less than or equal to 3x minus 1. Again, it's the same line. There's no difference. So our intercept is -1, put a dot. Our slope is 3, up 3, 1, 2, 3 over 1, put a dot. Now, because it's the equal on the bottom, now this is going to be a solid line between the dots. Solid line. Now, where's less than that line? Less than is below. Okay, so we have a below. Now, greater than would be above, less than is below. So we go ahead and shade below. Just kind of scribble it in. Problem 2 talks about using linear inequalities. It says the map shows the number of tickets needed for small or large rides at the fair. You do not want to spend more than $15 on tickets. How many small or large rides can you take? Okay, so if X is small rides and Y are large rides, let's try to figure out an equation that we can have for that. First thing you have to do is figure out how many tickets you can buy for $15. If you look here, it says tickets are 25 cents. So if you have $15, how many tickets can you buy? Well, divide that by 0.25, and that gives me about 60 tickets that I can buy for $15. Now, you don't want to spend more than $16, or than $15, I'm sorry, so that means 60 tickets. So what is my equation going to be? Well, if it takes 3 tickets to ride a small ride and 5 tickets to ride a large ride, it's got to be less than or equal to 60 tickets. Now, when you're looking at this equation, what I put was just the first quadrant because you're obviously not going to have negative amounts of tickets sold. So that's what we're going to do. So what we want to do is look at our intercepts. So cover up the y. You end up with 3x equals 60. Divided by 3x is 20. Okay, so your intercept is 20 on the x-axis. So if I go up by, 4. So 4, 8, 12, 16, 20. Put a dot, because there's your intercept right there. Okay? Now, what about the y? Well, 5y equals 60. Cover up the x. You get 5y equals 60. Y equals 12. So let's do the y-intercept. Again, let's go by 4s. 4, 8, 12. Put a dot. So there's your 2 dots. So your line here, it's less than or equal to, so it's a solid line connecting there. Now, anywhere in this realm is where you represent your answer to this equation. Now, going off what we learned yesterday, let's talk about absolute values. Well, first things first, let's subtract 1. So I end up with negative y less than the absolute value of x plus 2 minus 1. Now we still have to get the y by itself, so multiply the whole thing by negative 1. Now multiply by negative 1 here and this whole side by negative 1. Okay, so what do I end up with? Y. Now remember, it's an absolute value, so it's going to be greater than negative x plus 2 minus 1. Okay, let me clean this up a little bit. Remember, your vertex here is -2, -1. So we're going to go to there first. So -2, -1. I'm sorry, I messed up. This should be +1 because we multiply the whole thing by negative. So -2 + 1 right there. Now, my slope, remember, that represents my slope. So I'm going to go down 1 over 1, put a dot, and symmetrical on the other side. Okay. Now, because it's greater than, this is a dashed line. Something along those lines. Well, where's greater than that line at? Okay, well, greater than that line is going to be above it. Well, how do I shade above this? Well, it's simply just shaded above the absolute value. Problem 4 talks about writing the inequality that you see in the graph. Start with the vertex. Where's that vertex at? So my vertex is at 3, -2. Let's figure out what the A is now. So start from this point, go up 1 and over 1, so my slope is just 1. Okay, you can put A as 1 if you want to, that's fine. So let's write my equation. I'll keep it separate here, where I keep the y separate. We'll deal with the sign in a second. 1, but don't have to write it, absolute value of x minus 3 minus 2. Now, because it's not an equal to, it's not a solid line, and it's shaded, we know it's shaded above the absolute value, so it's going to be greater than. Now, the question is it a dashed line or solid? Well, it's dashed, so we don't need to add the or equal to, and that is my final answer.